this video we are going to see a company specific question. Okay, so basically when it comes to company specific, we have only two genres. One is service based, another is product based. Depending on the company you prefer to attend your placements, the question toughness range and all differs. Okay, so over here we are going to practice a question which is previously asked in Zoom. Okay, so you see, of course, you won't get these boxes kind of thing as output, but the values are the main features. So if you give an input of 5, we need this to be our output. And if you give input as 4, we need this to be our output. So before starting with this question comes under pattern based questions. Okay, we have how many rows? If you just check it out, we have 9 rows, sorry, 9 columns specifically, and 9 rows. Okay, so in the same way, when it comes to, okay, I'll just type it out. So this part is said to be a 9 into 9 matrix pattern. Okay, over here, if the input is 4, we get it as a 7 into 7 matrix. Okay, so if we check it out, when the input is 4, we get a 7 into 7 matrix. When the input is 5, we get 9 into 9 as a matrix. So what is this relativity between this 5 and 9 at the same time 4 and 7? So if you check it out, 5 ones are 5, 5 twos are 10. So what is 5 twos are? 10. So what about 4 twos are? 8. So you can just, now you can see the comparative over here. So 5 twos are 10, minus 1 is 9. 4 twos are 8, minus 1 is 7. So we are taking our first step to our code. You see, when an input is given, first when you get an input, before going to printing the values, we first of all need a storage space to store all these inputs. So since it is of rows and columns, we can go with 2D array. So in a 2D array, first of all, when we create array, there is a mandatory thing that we should give a size at least 4 columns. So when it comes under that manner, based on the input, now we are able to calculate our columns or rows that we need. It is just simply input into 2 minus 1. So whatever the input is, into 2 minus 1 is going to give you the row and column. Fine. Okay, this is base 1. So once we are done with this part, what is the next part? Our work is very much simple here. Our first part is to just keep these 5s in one line. Then once that part is done, we can assign in the next line, then in the next line, then in the next line. Okay, so just defining it is very much easy. Unlikely when we deal with 2D array, we just assign values in row wise, correct? Once first row is done, we go to next row, then we go to next row. But what I'm suggesting is when you give the values for the row, then for the last column, then for the last row, then for the first column. So here it goes. Column. Once these 4 are done, that means in these positions, if I assign 5, our next work is to assign 4. Where do we assign 4? In the second row, second last column, second last row, and second column. So everything just like this, it is pasted over here, but only with some changes. This is not first, rather it is second. Then, so in the same way, when we go to 3, it will be like third row, third last row, sorry, third last column, then third last row, then third column. We have to go work it out in this way. We just need 4 variables, that is row start, column start, row end, and column end. We can define our row start and column start in a very easy manner. So if the row start is always going to be 0, same goes for the column start, because the row start and column start are 0, 0, 0 in the beginning. But when it comes to row end and column end, since it is a 9 into 9 matrix or 7 into 7 matrix, which defines it is as a square matrix, so our size is gonna, like, row end is gonna be, which defines 9. Yes, correct. If the input given is 5 means it will define 9. But there is a problem. When we come to the last row and last column, it is not 9 comma 9. Technically, if you know what is a 2D matrix, it is defining 8. It is not 9. We need 8. That means the same input minus 1 we should write. Understood? So that's what is our work. Sorry, we have to give 8. So let us push these concepts into our code. First of all, our work is to get an input defining with what number are we gonna start. So here, if the input is 5, we take the input as 5 and somehow we convert that to 9. So let us start with that part in the beginning. Int, let us write num and let me scan that number. Once the number is scanned, our first duty is to create a variable called size and define it as num into 2 minus 1. Because as I said, if the number is 5, what is 5 into 2? 10. 10 minus 1? 9. Which exactly defines the number of rows and columns that we need. Once we have this size 9, all we have to do is create a matrix int a of rows as size and columns as size, as we do. Assign 5s in the first row, last column, last row and first column. That's what we are going to do. But you see, there are 4 things that we should do, right? First row, last column, last row, first column. Every single step will have every single individual loop. So you see, I will create 4 variables called as row start, column start, at the same time row end, column end, denoting in such a way that always our rows and columns start with 0, but our column end and row end defined by our size. So if our size is 10, you see, our num value is 5 and our size is 9. So our last index value of our 2D matrix will be size minus 1. Same goes for column end, size minus 1. If you see, our first work is dealing with the first row. That means our first row is constant. So if I say when I'm moving from this first 5, that is index 0, to the second 5, that is index 1, I'm not moving the row. What am I moving? I'm moving the column. So I should write a for loop in such a way that the column is moved. The column is moved in the forward direction. That means from column start to column end. That's what I'm gonna do. So column start, my I value will start from column start and it will go until column end, I plus plus. You see, in this code, what I will do, I'll write in such a way that a of, let the row be row start, but the column will be iterating with the I value, and let me assign the value called as num over here. So many might be wondering what is happening over here. So what I will do, I'll just create a for loop, to be precise nested for loop, which is basically used to either scan values or print values of a 2D matrix. I comma j, and let us have a new line. That's it. So yes, let me run this code and let me give an input of 5. Okay, that is too much of numbers. You see, we got too much of garbage values, but you can clearly see that we got 5s in the first row, which was clearly first step. The row is done. What is our next step? The last column. You see, let me recall the concept that we have already done. Okay, so let me recall the concept that we already done. All we did was we suggested that we are going to deal with the first row. So we are not moving the row, rather we are moving the column. That's what I've done to my code. In this selected for loop, I'm iterating my I value from column start to column end. That means moving from column start position to column end position. In every iteration, I was assigning my num value, that is 5, to this position. Correct? So yes, but you see, I was the one which is iterating, and it is kept in the index position of column, but the row position is having row start, denoting we are dealing with the first row. What if we are dealing with the last row? We would have kept it as a row end. So comparatively, let us come to the next one. That is, once we are done with the row, first row, we have to go to the last column. So here the column is gonna be the same, but you see, let us say like I have assigned these 5 values. That's what you will see when we view the output. In output we have given all the 5 values. How many 5 values? 9 5 values, including the last one. So to denote that, I'll give a highlighting also. But when we start with the last row, last column, you see that includes a value that is already given, right? So we have to eliminate this. We should not start with this. How can I do that? Okay, we'll deal with that. But before starting with that, eliminating this selected 5, let us think of whether we should iterate our row or else column. So see here in this line, the column is being the constant, rather the row is moving, and the row is moving from row start to row end. That means in our for loop, we are going to iterate. Just a minute. So in our next for loop, we are going to iterate our row because our column is constant. So I'll keep I is equal to row start. Oh wait, if we keep row start, you see this is our row start, right? Index 0 is our row start, and we are rewriting this 5 again, which is not needed, right? So what we should do hereafter, there is no need for row start to be 0, because in index 0, in row 0, whatever the values that has to be kept is already kept. As you can see in the output, already row 0's values have been assigned, so there is no need for our 0 to be row start hereafter. So what I will do, I'll move the row start from 0 to 1. How can I do that? Just add 1 to them. So once the first for loop has done its work, the immediate task that I do is row start plus plus, which will increase my row start from 0 to 1. So now my row start is 1 and my row end is still the last index 8. So there is no worries. Row start will be 1 and I can go less than or equal to row end, that means up to index 8 and I plus plus. Over here, as I said, we are moving our row. So my row should have I, but my column should have column end or else column start. See here, we are dealing with the last column here. So that should be column end, and that is equal to num. Let us check whether these two are working or not. So we have assigned, technically we have assigned these values and we are now assigning these values. So let me highlight it first of all. Yeah, once this part is done, let us move to the question. Yeah, you can see we got these as 5, and as we did with our second for loop, the last column also got as 5. Our next work is to assign 5's in this place, and as I said before, once we are done with the first row, we have to eliminate this extra column that we had, right? In the last column we had one extra 5, right? We were eliminating this using this row start plus plus, just reduced to one row. So in the same way, what we are going to do means, once we are done with this last column, this 5 should be eliminated. That means there is no need for the last column anymore. So if it is a starting column, we define it as column start. If it is an ending column, we define it as a column end. So all we have to do is just -1 in the column end. So for your definition, I'll just erase this part. So what we'll write here, the column end is 8, row end is 8 and column end is 8. But now hereafter, once the first two for loops are done, we are gonna change our column end to 7. How to do that? How to change 8 to 7? just column end minus minus. Are you able to understand? So once this part is done, we'll go to the fourth for loop. Okay, how can we design our fourth for loop? So everything is set as per the needs. Our third column is about last row. That means the row is gonna be the constant area. Only the column is gonna be moving. But here's the fun part. For the last two times, we were moving in the forward direction from index 0 to index 8. But this time, it is from index, our column values, index 7 to index 0. That means from column end to column start. Let us iterate it. So int I is equal to column end, and starting from there I can go up to column start, and I minus minus. So as I said here, the row is constant. The row is row end and it is a constant position. Only the column is moving, and then I'll place the num over here. So shall we check whether the code is working perfectly or not? Yes. So far so good. So we got our three sectors of the outer matrix as 5. Now time to go for the last one. That is the last column. So last row is done. So we are going to deal with last row is done. So our final part, that is first column. How to deal with our first column? So you see, as I said before, now one of the extra sectors should be eliminated. This is row end. Once this row end is done, there is no need to track up the row end. As index 8, let us change it to index 7. Part's done. So now for this line, for the unfinished line, you see the row start is 1 and our row start is denoting as 1, and our row end is 7. Row end is also denoting 7, but our column is 0, and you see column start is denoting 0. So every time when we finish one sector, if we update our row start, column start, row end and column end, it just updates itself to move to the next sector. Okay, so as I said here, in this part it is the first row, so the first column. So the column is constant, the row is going to be iterating in reverse, so from 7 to 1. Let's deal with it. So yes, we have to reduce the row end as we discussed, and after this the fourth and final for loop, where we will be iterating our row in reverse order, row end to start. And as I said, since the row is moving, I'll keep the I in the row index, and in the column index it will be like column start equal to num. That's all. So the final part is done, and once when we finish this final part, it is time to eliminate. Once we are done with this final part, it is time to eliminate our column start also, because column start is 0 and we are done with the 0th column. It will change to 1. That means, see here, what is the row start now? 1. Column start 1. That means our matrix is our outer matrix is no more alive. We start from 1, 1 and go up to 7, 7. So just the way we did for the 5, the next count will be doing the same for 4, then for 3, then for 2, then for 1. So we are reducing our row end and column end, and at the same time we are increasing our row start and column start, so that once we are done with one of the outer sector of our matrix, we move inside from 1, 1 to 7, 7. Then once we are done with 4, we move to 2, 2 to 6, 6. In the same way, once we reach 4, 4, that means when our row end and column end, row start and columns, that means when our row start and column end, as well as column start and row end, all the 4 factors become the same value, that's where we stand here, and that's where we end our program. So let us jump to the code again. So since we are done with the last column, column start, we have to increase the column start. So just these 4 code, as you can see, these 4 for loops. First for loop with a incrementation of row start, second for loop with a decrementation of column end, then third for loop
then fourth for loop. This is our source code which exactly fixes phi in the outer side of the matrix. So shall we check this out? You can see we are getting the outer area to be phi. So there are a few more works to be done so that we'll get the inner area also finished up. Before that, let us check for even 4 also. Is it working for 4? Yes. Is it working for 3? Of course, yes. Yeah. So what I'm gonna do means I'm gonna select this whole code. This is our source code that will be assigning 5 or 4 or 3, whatever it is, in the outer sector of our matrix and update it to the next level. Once I've copied that, all I'm gonna do is create a while loop where I will check like row start not equal to column end. So when the row start and column end is not being equal, at all those times I can be doing this work, working out this 4 for loop so that I will be assigning some values to my matrix. So let us check it out, which will be a absolute wrong answer, I can assure you, but we'll correct it later. What are we getting? We are getting every single value except the middle one. That means before correcting that inner matrix to be 4, 3, 2, 1 and all, I should correct the middle one. The last one value is not being assigned because of the while loop condition that you are given. So that let us make our duty to assign it at the last. A of row start column start equal to num. And let us check it out now. Are we getting the answer? For 5, yes, of course. For 3, yes, of course. But the problem is the pattern is working, but not the values. Once 3 is kept outside, the next work is to keep 2. That means since I've kept all the 4 for loops inside a while loop condition, it is assigning 3 to all the areas. But the only problem is once I'm done with the first 4 for loops, at the end, I should decrement my num. That is the sole purpose. Num minus minus. Now let us check it out. Simple as that. So let me give you a small recall. All we did was just to assign 5 in this first line, then in the first row, then in the last column, last row, first column. Once a code for this 4 operation is written, all I did was I kept it inside a while loop which will be iterating the same rules until we reached a midpoint. And when we reached the midpoint, I kept a separate code for to assign value in the midpoint. And yes, of course, this is the main factor. Updation. Without this, of course, we won't be getting our matrix as required. So let us check for some other numbers also. 4, yes, it is working out. 3, it is. And 7, of course, we'll get a big number, but still it works out. Yes. Okay, there are n number of patterns in this kind of way when it comes to Zoho questions. As far as the questions that been discussed in the last few years, Zoho mainly focus on string based and pattern based. And when it comes to pattern based, such as these, Zoho focuses on string based patterns or number based patterns. So I would recommend you to practice on those stuffs. Okay, thank you.